Good morning or evening, wherever you are in the world right now. It's a pleasure to join you for this Knowledge Management Conference. Today I'm going to be talking about preparing your knowledge for generative AI. The integration of artificial intelligence, and particularly generative artificial intelligence, into organisational operations is reshaping how knowledge is managed and utilised. To really harness the full potential of AI, you really must critically assess and prepare your knowledge assets. Today, I'm going to run you through some essential things to consider to ensure that your organisational knowledge is primed for effective AI integration. So here is an overview of what I'll discuss today. A little bit about understanding AI in knowledge management, some points around data quality and accessibility, developing AI-compatible knowledge structures, preparing to implement vector search, and some ethical considerations in AI implementation. So there's no doubt that generative AI enhances knowledge management. It can do this by automating the collection, organisation and dissemination of information. It can also enable real-time access to relevant knowledge, thereby improving decision-making and operational efficiency. For instance, AI can assist with efficient information retrieval, particularly with vector search, which I'm going to talk about in just a moment, scalability with knowledge repositories, and automation, which can really assist to ensure knowledge remains current and actionable. It can also generate new information almost instantly. So this is very helpful across most industries, and I'm sure you've experienced this already. However, it does pose a few risks and challenges, and I'm going to point some of these out now. Obviously, many of you will be familiar already with hallucinations, but from a knowledge management perspective, there are some others. So for example, using generative AI allows users to generate a greater quantity of information or knowledge, information that could be turned into knowledge, but not necessarily quality knowledge. Over time, if companies are using RAG models, so retrieval augmented generation, those generative AI tools will produce outputs which have been based on content which has been AI generated. So if you think about AI overlaying AI and AI generated material using AI generated material, and you just wonder where that loop starts and finishes. There are obviously potential errors due to people not reviewing and revising work that's been generated using an AI tool, or people using AI generated content instead of using templates or precedent documents. So I work in a large law firm, and I see this as quite a risk for lawyers. So that because it's so easy to have a tool generate new content, lawyers may tend to do that rather than relying on and using sort of a firm approved clause or document. That obviously has the flow-on effect of lessening consistency across the firm, which is obviously negative for client satisfaction, but it also puts at risk of a professional indemnity claim because people are not familiar with the content that they've just created, and they may not review it properly. So the old adage, garbage in, garbage out, absolutely rings true once you start working with AI-generated tools. Although one challenge is it can be hard to work out whether what has been produced is garbage, unless you're a subject matter expert, or on the other hand, maybe what the underlying source documents were, or even where they may be stored. So before we chat about data, I think it'll be helpful to give a brief definition of the difference between data, information, and knowledge. So here's a simple and clear definition. Think about data as raw facts and figures without context. So for example, 25 degrees Celsius, or a date such as the 12th of November 2024, they're data points that lack meaning on their own. Information, on the other hand, is data that's been organised, processed, or contextualised to provide some meaning. So for example, you could say the temperature today is 25 degrees Celsius. So that adds context to the raw data, making it useful. Knowledge, on the other hand, is the application of information combined with experience, insights, or understanding to guide decisions or actions. So for example, when the temperature is 25 degrees Celsius, it's comfortable to have an outdoor meeting. That applies understanding to the information. So these principles apply to data generally, but can be applied to information and knowledge as relevant. Hopefully each of your organisations does have a data governance policy and also some frameworks in place. And someone has put some thought into how data, information and knowledge should be categorised and stored. So if you are embarking on setting up some generative AI tools, first port of call I would recommend is to seek out the people in your organisation who are responsible for data governance. So on the next slide, I'm going to do a little bit of a deep dive into taxonomies and metadata. So traditional knowledge management systems might not align seamlessly with AI technology. So in order to bridge this gap, recommended that for ontologies and taxonomies, you develop comprehensive ontologies that define relationships between concepts, enabling AI systems to interpret and utilise knowledge effectively. Standardise your metadata. So standardise it to facilitate efficient data retrieval and processing by AI algorithms. And so a good example of this might be where you're seeking to use knowledge stored within a SharePoint repository, as well as knowledge within a document management system. And the terms that you have set up in the SharePoint term store might be different to the underlying metadata you have with other systems. So in the case of SharePoint and another document management system, the lack of a unified ontology means that AI may struggle to interpret and connect similar concepts that are labelled or structured differently. The metadata allows the AI to retrieve and process information efficiently. However, if you have discrepancies in your metadata standards between those systems, it can actually create barriers for the AI in identifying commonalities, trends, or relevant data. So, these semantic inconsistencies in the way that terms and relationships are defined can cause issues. You can have interoperability issues. So where without a unified metadata framework or ontology, AI may require additional layers of processing, such as mapping or transforming metadata between systems, increasing complexity. And overall, it effectively has a reduced effectiveness on the AI algorithms. So non-standardized metadata and fragmented ontologies can diminish the ability of AI to perform tasks like search, natural language processing, or knowledge graph generation. So a lot of people are now looking to implement vector search across their knowledge repositories, including our firm. So vector search is a modern search technique that goes beyond traditional keyword matching to help you find information based on meaning and context. So instead of looking for exact word matches, vector search uses machine learning to understand the relationships and similarities between words, phrases, and images, between words, phrases, and even images. So it works by turning your data into mathematical representations called vectors and comparing them in a multi-dimensional space. So this approach allows users to find relevant information, even if their search terms don't exactly match the stored data, making it ideal for large, complex, or unstructured knowledge repositories. So for example, if a user were to search for the term team collaboration, a vector search might surface content about working together, group projects, or cross-functional teams, because it understands the broader meaning, not just the specific words. So this makes it especially powerful for knowledge managers aiming to improve how employees find and use information. So in order to prepare your knowledge repositories for vector search, I recommend some work be undertaken. So the first one is to organise and clean your content. So before adopting vector search, review your knowledge repositories to ensure that the content is relevant, up-to-date, and well organised. Remove any duplicates or outdated materials and categorise your data logically. This step helps the system focus on high-quality information and reduces noise in your search results. Secondly, standardise your knowledge. So ensure that your data is in a consistent format. For text-based content, this might involve cleaning up inconsistencies in style or removing unnecessary formatting. For images or multimedia, make sure they're properly labelled and tagged to make them easier to index and search. Leverage the metadata that you have. So good metadata, such as summaries, keywords, and tags, it really does add an extra layer of structure to your knowledge. So even though vector search can understand unstructured data and can do full text searching and look at, much more context around a document rather than just the pieces of metadata, having enriched metadata does improve its performance and ensures more relevant results. And one of the great things about AI is that we now have AI-driven auto classifiers. So if you have a large content of data or information knowledge that doesn't have well-defined metadata, you can use one of these tools to apply that metadata retrospectively, which is fantastic because remapping of metadata is one of the key things that prevents people from actually getting a lot of their knowledge in order because it's time-consuming. And then further, choose or fine-tune the models for your organisation. So the vector search relies on what are called embeddings to turn your data into vectors. So many general purpose models are available, but you might need to fine tune them to reflect the specific language, jargon, or priorities of your organisation. And this will ensure that the search system understands your knowledge in a way that's meaningful to your users. Pre-process your data thoughtfully. So pre-processing is about preparing your data for the vectorization process. So this might include breaking down documents into smaller chunks, like paragraphs or sentences, to make them easier to search. For multimedia, it could mean optimizing file quality and adding descriptive captions. So normally that sort of breaking down and chunking data would be done by people who have some level of sophistication with large language models within your organization. And then the last one is to test and adjust. So once your data is prepared, start testing the vector search system with real user queries and pay attention to what's working well and what's not. And that feedback will obviously help you refine your models and improve the search results over time. So while vector search technology is powerful, its success depends on the quality and organisation of your knowledge repositories. So by investing this time upfront to clean, structure and enrich your data, you can unlock the full potential of vector search. And this means faster, more accurate searches for your team and a more effective way to tap into your organisation's collective knowledge. So as a lawyer or a recovering lawyer, it would be amiss of me to not talk about some of the ethical considerations in AI implementation. And I think what's happened is a lot of people have sort of gone out, experimented, had a bit of fun, worked, got their head around how these tools work. And now people are realising that actually we need some pretty strict governance and ethical frameworks in place within our organisations on how these tools should be used. So ensuring fairness and transparency in AI really involves addressing the biases in algorithms and maintaining accountability. So it's crucial to identify and mitigate those biases for ethical outcomes and enhance transparency for better accountability. Generative AI can unintentionally perpetuate biases from its training data, leading to unfair or exclusionary outcomes. So I think you're all familiar with how biased Google is if you were to go and ask it to generate images or search images for a particular type of career or type of person. It will, generally be a little bit stereotypical. A lot of these large language models that you've used have used effectively data that's been scraped off the web, some of it, legally, and some of it more, not so legal. And so you really need to be realizing that these models that you're using have been trained on quite biased information. And in the work context, sometimes that may not actually come through and it may not be as relevant, but you just need to be mindful of what is the underlying data it's been trained on to the extent that you know. And that's one of the challenges is we don't actually know what these models have been trained on, and we actually will never know because that will never be made transparent to us. So really, we would recommend organisations train AI on diverse data sets and conduct regular audits for things like bias. But also encourage your employees to critically assess AI outputs to ensure that a more inclusive and equitable approach to knowledge management is taken. Ensure that you have measures in place to ensure that any information that is being used to generate knowledge is unbiased. AI systems often handle sensitive data, so creating risks around privacy and confidentiality. Robust data security measures such as anonymization and strict access controls are essential. And, obviously it's important that you never upload any personal information into any of these generative AI tools. Clear policies and employee training on ethical AI use will help safeguard information and build trust amongst your stakeholders and also your clients. AI-generated content may occasionally be misleading and inaccurate, as we already know, which really highlights the need for human oversight. So defining accountability for AI outputs ensures that errors are addressed promptly. Transparency within the organisation. So we recommend that anyone using a generative AI tool, even for a part of their work, whether it was a piece of legal research or the first draft of a document, that you disclose that to the people in your team or the people who are reviewing that work, so that they're aware and that they can take a lens to the work whilst they're reviewing it. Transparency about how the AI operates and its limitations fosters trust and supports responsible integration into workflows, and that's really important. So the key takeaways from today's presentation. Before you consider implementing any generative AI tool, in particular, I'm talking about, RAG models where you might be uploading some of your own knowledge into it, or implementing vector search, for example, then really consider the state of those knowledge repositories. Have a look at your metadata, your taxonomies, look at the quality of the documents. Less is more in some cases. A lot of these RAG tools actually work better on, say, 10 examples rather than they do, on 100. So play around with the number of examples that you use and the quality of the outputs that you get. Speak to any data governance subject matter experts within your organisation and get your hands on data governance policies, any AI governance policies or frameworks that you might have. They may be still in development. But first of all, finally, really just experiment with the AI, really give your people permission to play. It's only through using these tools and playing around with them that you will really learn to understand how they actually work, and have fun. If anyone would like to connect with me on LinkedIn, I would be most welcome to be a contact. And I will now open for questions. Thank you very much.